Okay, so here we have chapter 1 of the midterm review packet. I'm going to go through these answers for everybody. Just before I begin, just remember that, um, you know, not everything that's on the exam is in the packet. You should study all your notes, all your quizzes, all your tests. You should study a lot more. And, the best way to study is not just to do all the problems in this packet and then call it a day. Obviously, the ones that you do well on, great. Focus on the ones that you struggle with and go get more practice with them in the textbook and previous assignments. But with that said and done, we'll just go through and get these problems out of the way. So here we have to find the equation of a line passing through the point, -2, 5, with a slope of 2/3. I'm actually going to slide this over so I have a little bit more room to work. I recommend that when you're working on these, you spread out a lot and use a lot of papers to do this. So whenever we have an equation of a line, we have a point and we have a slope, we're going to use point-slope form. That's y minus y1 equals m times x minus x1. This is xy, so we're going to have y minus 5 equals 2/3 times x minus a -2. So we're going to have y minus 5. When we distribute, we get 2/3 x. That's going to be plus 2. So we're going to have plus 4/3. This minus 15 is 15, sorry, this minus 5 is 15 over 3. So we're going to have y equals 2/3 x plus 4/3 plus 15/3. So we get y equals 2/3 x plus 19/3. And it says leave in slope-intercept form, and that's what this is. So that is our answer. The next one, we want to find the equation with a line that's parallel and passing through the point. So we want to leave this in standard form. So, whoops, I want to cross it out. Standard form is ax plus by equals c. The important thing here is we have this slope. So what we want to do is we want to start again with, and I'll change the color up for this one. We want to start with point slope form. So y minus y1 equals m times x minus x1. Parallel lines have the same slopes, so the point is going to be y is -1, so y minus -1 is plus 1. The m is -1/2, and the x value is going to be 4. So we distribute this in, we get y plus 1 equals -1/2 x. That's going to be a plus 2, and we subtract the 1. So up here we get y equals -1/2 x plus 1. Now we want to get it in ax plus by equals c, so the x is going to be on the other side. So we get 1/2 x plus y equals 1. But we want to have no fractions. So what we're going to do is we're going to multiply everything by 2. If we multiply each term by 2, then everything stays nice and balanced. So if I multiply 1/2 by 2, I get x plus 2y equals 2. And that is the answer. That's it. All right, moving on. Now we have the same thing, but we have a perpendicular and another point. We want to leave a slope-intercept form. So as you can kind of see with all these, it's all about manipulating. And so here, this is not in slope-intercept form, so I don't know what the slope is. So I'm just going to put it into slope-intercept form so I can see what the slope is. So -2y is equal to -6x plus 3. So y, if I divide everything by -2, is equal to 3x minus 3/2. This is the important part. Perpendicular, so I only really care about the slope. So again, I'm going to do y minus y1 equals m times x minus x1. Point slope form is great for finding these equations. The point is 5, negative 3, so I put in the net minus the negative 3 there. This slope is really 3, so the line that's going to be perpendicular is going to have opposite reciprocal, so negative 1/3, and x minus 5. So simplifying, I get y plus 3 equals negative 1/3 x plus 5/3. This positive 3 is really 9/3. So I'm going to have y equals negative 1/3 x plus 5/3 minus 9/3. Combining the fractions gives me y equals negative 1/3 x minus 4/3. Put a little box around my answer so I know that's it. So here a little bit of fractions, but overall pretty straightforward process. Right, equation with a line with x-intercepts of 3 and y-intercept of negative 4. Oh boy, a few steps with this one. Let's go with orange. Okay. So we need to know a point, we need to know slope. Well, we actually have 2 points here, which is nice. So here the y-intercept is negative 4. So that gives us the point 0, negative 4. X-intercept of 3 gives us the point 3, 0. Don't forget that the slope, m, is change in y over change of x. So if I do negative 4 minus 0, I get negative 4. And then 0 minus 3 is negative 3. So that gives me 4/3. So I plug this into the formula, y minus y1 equals m times x minus x1. And I get y. I can really choose whichever point I want. Given that this is a fraction slope, I'm actually going to choose x to be 0. So I'm going to have plus 4 equals 4/3 x minus 0. Now you can see when I distribute this, I just get 4/3 x minus 0 minus the 4, and that is my answer. So a couple steps with this one, where you had to first find the slope. Well, first realize that these are points. Use those to get the slope, and then choose one of the points to get the equation. If you chose the x-intercept, still would have gotten the same equation, so no worries there. Are the following functions? Okay, well, what we have with all of these, you need to look at really the vertical line test. Remember, if something is a function, when it doesn't have more outputs per input. So if you're looking at your standard coordinates here, whoops, you have your x-axis, which are your inputs, and your y-axis, which are your outputs. So if I have an input there, I should have at most 1 output. If I have 2, it's not a function. And you can see a lot of people remember the vertical line test. If I draw a vertical line through those points, it touches 2 points, so it's not a function. So that's why something like, sideways parabola is not a function. So nice little trick with all this is looking at the values of whether or not these are functions, recognizing the patterns. This right here, y equals 6x minus 2. That's a line. Any line is a function. It's a one-to-one relationship. So is this a function? Yes. Same with this. This is standard form of a line. Yes, that is a function. This right here, this is a parabola. ax squared plus bx plus c. The bx is 0, but it's still just a parabola. So yes, that's also a function. Here, you might be able to see it, but if you want to, you could solve for y. If you solve for y, you add the 2, so you get x plus 2, and then you take the square root. But when you take a square root, you need to have a plus or minus. That right there, that plus or minus gives you 2 values. If I have, when x is 2, I have the square root of 4. 2 plus 2 is 4. So I have the square root of 4, but I have the plus or minus. So I have a positive 2 and a negative 2. That gives me 2 y values. So that is not a function. Now for e, this is just the positive square roots. There is no plus or minus. So is this a function? Yes. For these points, again, we can't have a duplicate y value. So we look at all these y values. Are any of them duplicates? No. So is this a function? Yes. But for g, we can see that these 2 points have the same y value of, oh wait, sorry, for this one, we're not looking for the same y value. If we're looking for vertical points, we're looking for the same x value. My fault. Right there, right there. Same x value, that means that those points are on top of each other. If they're on top of each other, that means it's not a function. Whereas this, they all have different x values. So yes, this is a function. Sorry about that little confusion there. And finally, for number 6 here on this first page, we have to evaluate the function. So wherever we have an x, we're going to replace it with a negative 2. So f of negative 2 is going to be 3 over 2 times negative 2 plus 1. So we get 3 over negative 4 plus 1, which is 3 over negative 3, which is negative 1. That's nice. Here, f of 0, we're going to have 3 over 2 times 0 plus 1. Well, that's just 3 over 1, which is 3. And finally, we have f of a. That's just 3 over 2 times a plus 1. Wherever you have an x, you replace it with that value. And so we have this. It should be an a. It's a really ugly a. So why don't I take the time right now and clean that up? Well, not much better, but somewhat. All right, and that's the first page. On to the second page. Oh boy, and then the third page. Oh boy, okay. All right, here we go. Number 7, second page. I'll move this over so I got some room to work. Domain of each function. Here, you could save yourself some time. Remember, domain is the x value, so this is a straight line. So domain is going to be negative infinity to positive infinity. That's it. Where does it start? Where does it end? There. For b, this is a parabola. This is vertex form of a parabola. Same deal. The domain, what could it be? What could the x values be? A parabola could be any x value. Domain is boundless. All right, this one, what could x be? Well, this is a fraction. In a fraction, what can't happen in a fraction? The denominator cannot be 0. So x squared minus 3x minus 10 cannot be 0. So what I do is I factor it. X minus 5 times x plus 2 cannot be 0. So if I solve both of these, I get x cannot be equal to 5. X cannot be equal to negative 2. So if I write this in interval notation, I start with the smallest value that can be x, and that of course is negative infinity. And then I go all the way from negative infinity to the next smallest number, which is negative 2. And I stop. Because I can't be equal, because x cannot be equal to negative 2, I have parentheses and not a bracket. And then after negative 2, it goes all the way into 5. And then again, it can't equal 5, so I stop. And then after 5, I continue all the way to infinity. That's the answer. The hard part about this may be the interval notation. So work on that, but at least realize that x cannot be 5 or -2, because if it is, the denominator is 0 and the fraction doesn't exist. Oh, excuse me. All right. So with this one, again, here, this is a square root. You can't take a square root of a negative number. So that means anything underneath the square root, the 2x plus 8, must be greater than or equal to 0. So if I solve this, I get x is greater than or equal to -4. Because here, greater than or equal to, x can equal that, I do a hard bracket, -4, all the way up to positive infinity. And there we go. And then finally, for this one, kind of a double whammy. Again, the denominator can't be equal to 0, but we can't have this square root be less than 0. So what we'll do first is we'll do 3 minus x. Well, we'll do greater than or equal to 0. No, sorry. We'll do 3 minus x. Cannot be. Oh boy, I'm all. This is what you get when you try to to do math after a long day, guys. Luckily, your exam is early in the morning, so you'll be fine. 3 minus x is greater than or equal to 0. So we're going to get, if I switch this around, 3 is going to be greater than or equal to x. And if I write that like this, x is less than or equal to 3. However, if x is 3, I get 3 minus 3, which is 0. That's not going to work. So that means that x is going to be strictly less than 3. So again, I start with the smallest number, which is negative infinity, and it goes all the way up to 3. But if x is equal to 3, this is 0, the denominator is 0, fraction's undefined. So I put a parenthesis because the parenthesis stands for, hey, it goes all the way up to 3, so close to 3, but never actually touches it. Whereas in the previous one, these brackets mean, hey, it actually touches -4. All right, domain and range for these problems. Right, so again, please recognize, look, you could work this out a whole bunch of different ways, but this is standard form of a line. And a line, the domain, let me label these. The domain is just going to be negative infinity to positive infinity. Done deal. Same with the range. It's a line. It goes on forever. Assuming, oh, it got rid of everything. Assuming we can actually write this. Okay. That's the first one. Oh, green. Okay, here we go. Let's look at C, because B is a little bit tricky. What is this? You have to recognize that this is A times x minus h squared plus k. This is a parabola with, that doesn't help me. Oh, I got all my colors mixed up. Yeah. This is a parabola with a vertex of 1, 4. H, K. So with the vertex of 1, 4, again, with a parabola domain here, it's going to go on forever. It's going to go negative infinity, positive infinity. Now the range, though, oh boy, the range is tricky. It's going to be everything, well, if you have a parabola, if it goes down, the vertex is the maximum. If it goes up, vertex is the minimum. Here, because this coefficient is negative, that means it opens down, so the vertex is actually the maximum. So the range, the y values, are everything from negative infinity all the way up to the largest y value, which is at the vertex, which is 4. So, as I figured this out, let me just say, hope my computer works. As you go through and work with this, do realize and do understand. I'm not going to be able to. Clearly, this is what you tuned in to watch, right? Anyway, that's the answer. Just circle it. As you go through this, look, this is going to be a really difficult problem if you don't realize that this is a parabola. But as soon as you look at this and see, that's vertex form of a parabola, real quick, became really quick. All right, and then for this one, this is a little bit tricky. This is your absolute value functions. But here you actually have, so absolute value functions look like this. They look like a V. So again, your domain for this one is going to be all real numbers, so negative infinity to positive infinity. But the range is going to be a little bit different. So let's say, for example, you do forget. Like if you don't realize that this is vertex form, multiply it out, you'll get the vertex. Here, if you don't remember how to get the vertex from this, try to graph this, play around with it. So here, draw a quick little grid. When x is 2, you get that y is equal to 3, right? Because this is going to be absolute value of 0. Well, when x is, let's say, 1, you get 3 plus the absolute value of negative 1, which is 4. So 1, 4. And when x is 3, same deal. You get 3 plus absolute value of 1. So you get up there, and there you can see, oh, hey, look. This is like a little V. This right here, this 2, 3, is the lowest point. So the lowest y value is 3, and the highest is going to go all the way up to positive infinity. And so that's my range. Graphs are a great little tool to help figure this out. Actually, no, I'll leave that little picture there. So maybe, I don't know, take a look. Okay, this is a little bit different. I didn't focus about this too much, but if you have f of x plus h, you're just replacing the x with x plus h. So, f of x plus h equals x plus h squared minus 3 times x plus h plus 4. So as we go through this, we're going to have, if I simplify this down, it's going to be x squared plus 2xh plus h squared minus 3x minus 3h plus 4. And we're subtracting f of x, so that means we subtract every term here. So minus x squared plus 3x because it's minus a negative, and then minus 4. Why don't I cheat to draw a straight line? Or I guess that wasn't straight to begin with. And then the denominator is just going to be h. So what I'm going to do here is I'm going to look for any of my like terms. And I can see that I have an x squared and an x squared. What else do I have? Oh, I have a negative 3x and a positive 3x, and I have a positive 4 and a negative 4. If you take a real good look at these, you can kind of actually see they're all opposite. So x squared minus x squared is 0. Negative 3x plus 3x is 0, and the 4 minus the 4 is 0. So if I just clean this up, I get h squared plus 2xh minus 3h over h. All these h's, there we go. Each term has an h. So I can reduce that, and then this simply becomes h plus 2x minus 3. And that, whoops, that is my final answer. Okay. So here, excuse me, just compositions, combinations of functions, just plugging it in, foiling, all your basic algebra stuff. All right, just a little bit off to the edge. Parent functions. Okay. So yeah, let's just go through this. So here, this looks like a square root. So the parent function would be f of x equals the square root of x. Here we're subtracting 5 from the x. So that's going to be a shift to the right 5. That's it. Here we're adding 2 on to the overall value. So this is going to be a shift up in the positive 2 direction. So we're adding 2. Domain of the function. Oh, did I not do enough of these domain and range problems already? See, this is what I'm saying. Like, if you've been cruising with these domain and range problems, you've done too much. Stop doing that. Go study something else more difficult. But if you are still struggling, I guess we got to go do that. So let's do that. All right, domain of the function. Oh, well, here, I mean, the vertex here, this is going to be 0, 0. So if we're shifting to the right 5 and up 2, the domain of the function is, this is square root. Yeah, domain of the function is going to be everything from 5 all the way to positive infinity. Because this is square root, right? Square root looks like that. And the range is going to be everything above 2. So the range is going to be from 2 to positive infinity. Yeah, and that'll be nice. Okay, the next one. What's the parent function here? Well, the parent function is going to be, well, if we could see, that's an absolute value sign there. So the parent function, oops, is going to be f of x is equal to absolute value of x. Here, a whole bunch of stuff is going on. We see again that positive 2 next to the x, so that means we're going to shift the opposite way. So shift left 2. We have a minus 1 on the end, so we are going to shift down because we're subtracting from the y value 1. And here, this means we're going to, remember, if it's a fraction, we're going to shrink. Here, we're going to, oh, what was the what was the word we used in class? Expand. Whatever. We'll say expand. Stretch. That's the word. Stretch. Stretch Armstrong. We're going to stretch by factor of -3. Yeah, so it's going to be a little bit wider. Okay. Oh. Sorry. it's going to stretch by a factor of 3, and then the negative means it flips along the x-axis. So there's a lot there. Probably could have used the type feature. So it flips along the x-axis. Domain of the function. So again, if we are shifting to the left 2, and we're shifting, we're shifting to the left 2. Oh, sorry. Yeah, another long day. Absolute value always looks like a V. So what's the domain? Negative infinity to positive infinity. What's the range? Normally this would be positioned at the origin, 0, 0, but we've shifted down 1. So the range is going to be from -1 to positive infinity. Then we have our last one, parent function here. This is just going to be a basic f of x is equal to 1 over x. What's the transformation? If we can see, we're switching, we are shifting to the right 6 because we're subtracting from the actual x value inside. And so the domain, right, so the domain of this, normally if we had this, domain is going to be from negative infinity to positive 6, and then from positive 6 to, positive infinity. Right, sorry. I'm way too tired to be doing this right now. I need some coffee. If you guys get tired when you're studying, make sure you take a break. All right, anyway, so again, this is again, it's all real numbers except for 0. So if I shift it to the right, it's going to be all real numbers except for 6. There we go, that's what I'm trying to do. So I'm going to do negative infinity to 6, and then from 6 to positive infinity. I ran out of room there. Okay, and finally we have the range. Interesting note, the range here, that actually is a horizontal asymptote, believe it or not. If you look at your horizontal asymptote rules, the degree in the numerator is 0 for the variable, and the degree in the denominator is 1. So since the degree is greater, that means the horizontal asymptote is y equals 0. So the range is going to be from negative infinity to 0, and then from 0 to positive infinity. I will take a quick moment to just say, this is actually the appropriate way to do this. This U means union. It means this part with this part. I haven't really been focusing a lot on that, only because, how do I put this? There have been a lot of problems with understanding the basics of interval notation. So let's focus on this. If you want to put in the U's, if you know how to use the U's, or you work with a tutor who uses U's, the unions, the correct notation, great, go for it. But if you're struggling with that, don't worry about it. This is fine. This is how you do interval notation for us. And then I'll get you the job. All right, last page. I hope so. I so hope so. We have this. We want to combine and look at these functions. So let's look at all these different combinations, colors. So here, f plus g of x, that means we're just adding these two functions. So we have x squared minus 1 plus 2x plus 3, combine the like terms. So we get, an ugly x. It deletes the whole thing. We get x squared plus 2x minus 1 plus 3 is plus 2. And, if only I can get this box thing. Did I still mess up this box? Well, that one works. That's the square. I want the rectangle. Oh, I got it. Oh, it works again. Okay. Just a crazy man doing math. F minus g, so here we're going to subtract. So we have x squared minus 1, and now we're going to minus. So minus 2x minus 3. Combine the like terms again. Again, this is minus 2x minus 3. You have to subtract both terms. So we get x squared minus 2x minus 4. And that's our correct answer there. And finally, f times g. This is a times, it's a dot. This is a composition of a function, g of f of x, f of g of x. This is multiplication, so we multiply. So we get x squared minus 1 times 2x plus 3. I'm really struggling with my x's. So we get x squared times 2x is 2x to the third. X squared plus 3 is plus 3x squared minus 2x minus 3. That's it. Here, f plus g. Whoa, no, it's not x anymore. It's negative 2. So here we're just going to have the f plus g function, which we know is x squared plus 2x plus 3. And that's this part here. It's a 3. It's an ugly 3, but it's a 3. And instead of x, we're replacing the x with a negative 2. So we get negative 2 squared plus 2, yeah, it's a 2, times negative 2 plus 3. So we get 4 minus 4 plus 3, so that just equals 3. Done. Okay. All right, f of g of x. This is the same thing as f of g of x. Be comfortable with both forms of the notation. Here we have the f function, which is x squared minus 1. We replace the x with the g function, so 2x plus 3. If we FOIL this out, we're going to get 4x squared. That's plus 6x, so that's plus 12x. Plus 9 minus 1. Combine the like terms to get 4x squared plus 12x plus 8. And that's it. Next up, g of f of x. So here we are going to have, again, this is the same thing as g of f of x. And so this is going to be replacing the x in the g function. So you have the g function is 2x plus 3. It's 2 blank plus 3. We put in the value of x there. So we're going to get 2x squared minus 2 plus 3, which is 2x squared plus 1. Whoops, nothing else to do, so we're done. That's it. Okay. Here, verify that these are the inverses. Yes, know how to read, write interval notation. If you don't mind, I'm actually going to, real quick, get rid of that. So now I can do the space. Find the inverse and then verify. So for this, for A, in order to find the inverse, remember we want to switch the x and the y, so we're going to get x equals 1/2 y minus 8. And then we solve for y, so x plus 8 equals 1/2 y times 2, so we get 2x plus 16 equals y. But this is an inverse, so we denote it with a -1 exponent. Now we need to verify, so what we need to do is plug the original, or plug the inverse into the original. So if we do that, f of inverse of f of x, yeah, we basically just take the original function. So that's going to be 1/2 x, but instead of x, we're going to put in the 2x plus 16 and minus 8. So here we're going to get x plus 8 minus 8. The plus 8 minus 8 reduces, so we get x. And then we want to have the inverse of f of x. Yeah. Which means we take the inverse, which is 2x plus 16, and we put in the original function in for x. So here we're going to have x minus 4. No, sorry. Lost it all. We're going to have x minus 16 plus 16. So we just get x, or, two c's facing each other. Right, so when we get that, boom, boom, x, done. Once we have x for both of these, that means that we can verify, or we know that these are inverses of each other. For b, we want to switch the x and the y, so we get x is equal to y plus 3 over 6. So we're going to multiply both sides by 6, so we get 6x equals y plus 3. Subtract the 3, so we get 6x minus 3 equals the inverse of y. That's an equal sign, just an ugly one. And then so what we want to do, again, we want to verify. So we're going to plug the inverse into the original. So the inverse into the original. There's the inverse, there's the original. So the original is x plus 3. So we're going to do 6x minus 3 plus 3 over 6. Minus 3 plus 3 cancels. 6 divided by 6 is 6, so we get x. And finally, the inverse of f of x, however you want to say it, I don't know. Oh boy, it's been a long process, right? Been a long video. I hope you didn't watch the entire time. Right, so we're going to plug the original into the inverse. So the inverse is 6x minus 3, so we're going to take 6, plug in the x plus 3 over 6 minus 3. Here, the 6's cancel out, so we get x plus 3 minus 3, or we reduce to x. So because, again, that is it, we know that that is verified as the inverse. So what I probably want to do is say that this is my inverse, and also that this is my inverse. Watch your notation. If you're in my class, a lot of people, when we took a test on this, lost a lot of points for improper notation. So make sure that you do have at least the y to the negative first. And that's it. So again, you should not really be just doing this to do it. This is not busy work. Don't just study a lot. Study effectively, and let me know if you have questions.